Assalamu alaikum students. I hope you are doing good and we are studying a course Disconnection approach. Today we will discuss the guidelines of disconnection. Students, while disconnecting a molecule, a target molecule, a product molecule, some basic guidelines would be in our fingertips. And students, you have keep these guidelines in your mind while disconnecting a target molecule. The first guideline is recognize the functional group in target molecule. Student, the target molecule, the first thing you have to find out the functional group in your target molecule. It is a very first and basic guideline. The second guideline is for compounds consisting of two parts joined by a heteroatom, disconnect next to the heteroatom. Student, you have to break a bond between carbon and which is attached to the heteroatom. You need to be disconnect the bond between carbon and heteroatom. You will understand this point from the example. Here is an example. Student, it is a target molecule. And now find the functional group first according to our first guideline. Here is a ether functional group. Carbon, oxygen, carbon. In second guideline, we have to disconnect a molecule in next to heteroatom. What is heteroatom? Other than carbon atom is said to be heteroatom, and here heteroatom is oxygen. Student, there are two possibilities to disconnect this molecule, but which one is preferable? It is totally depends upon our basic concepts, basic knowledge and our sharp mental thinking. Student, here two routes, one mentioned is A, another mentioned is B. Mean we can disconnect these target molecules in two ways or in 2 points. We will see both one by one and at the end we conclude that which one is the preferable. So first we will disconnect the route A, carbon and oxygen. This bond we will split or disconnect. Here is on the retrosynthetic arrow on which we have mentioned that carbon oxygen bond disconnect and it is a route A. When we disconnect it, this carbon, aromatic ring carbon, attain positive charge, while due to high electronegativity oxygen as compared to the carbon, it is a negative charge appear on this molecule, this fragment. And these positive and negative charge species are said to be the synthons. And now it will convert into synthetic equivalent while providing their counter ions. And it is undergo to like this. This was the route A. So, if we see here in route B, again this carbon and this oxygen, between these bond break and it is a route B. This route B, this one. According to route B, when we disconnect here, this oxygen due to electronegativity high, it attain negative charge, and this carbon which is attached to this aromatic ring, it is positively charged. And now these positive negative ionic species are said to be the synthon, and now provide their counter ions and it will undergo to this. Like oxygen, it is a negative charge species and provided it to positive charge species hydrogen. And here this carbon is positive and it gives a chlorine. are halogen atoms. So what we conclude? Here is a conclusion. In route A, it is not preferred, and definitely then route B will be preferable or preferred. But what is the reason? Student, keep in mind that disconnection next to aromatic ring should not be priority. Students, again, disconnection next to aromatic ring should not be priority. And what we have to do in route A? We disconnect the disconnection from aromatic ring carbon, which is not would be our priority. And this is our second guidelines. Prefer the disconnection next to heteroatom. Mean this is the heteroatom and prefer it from next side, not from this side. So I hope you understand this lecture. Kindly share your feedback. Thank you.